Hello and welcome. Today we'll be talking about big data and three of the challenges big data faces. I'm Sam Kratzis.
I'm Connor.
I'm Dylan Johnson.
I'm Kyle Cox.
So what is big data? Well, here are three definitions. The NIST talks about how it's an extensive data set that requires a scalable architecture for persistent storage, manipulation, and analysis. Google refers to big data as something that is too expensive to store, manage, analysis using traditional database systems. And then Merriam-Webster talks about how an accumulation of data that is too large and complex for processing by traditional database management tools. So really kind of general idea here is big data is a large set of data that can't be handled efficiently by normal database means. Doug Laney here came up with the three V's of big data: volume, velocity, and variety. Variety is when we're talking about the structure of the data. Is it unstructured? Is it structured? Unstructured would be like the raw, just an email message, kind of that raw body. And more structured would maybe be like a Facebook friends list. And then velocity, we're referring to how long something takes to generate this data. Like Amazon purchase history would be instantaneously, but a grocery store kind of logging its inventory, that wouldn't be instantaneous. So that really probably wouldn't be big data. And then volume, obviously big or small. And this one obviously is kind of interesting because this can be the most flexible and this changes a lot. One time I saw a terabyte is considered big data, which seems to be really outdated because I know a lot of like video game systems now, they store 1 terabyte hard drives. So then I'm seeing things like a petabyte, which is 1 million gigabytes, is kind of that threshold for big data. Big data was first logged, but not by this name, in 1663 when a scientist named John Grott dealt with an unmanageable large set of data when trying to study the bubonic plague as it ravaged Europe. Then, in the late 1800s, the U.S. Census was having a hard time processing all the written data, so Herman Hollerith created a punch hole system that turned 10 years of logging this data into 3 months. This started this big idea of really turning written data into tech data, and obviously computers help solve this. In 1965, this expanded to when the government created the first data center to store fingerprints and social security numbers and stuff like that. And then this really just evolved from there, from bigger data centers to bigger data needs to bigger data sets. In 2005, the term big data was first used by Roger Molasis, and it just kind of evolved from there. Nearly every company uses data. Now, if we're talking about data or big data, a company like Maya's probably has data, but is that not really big data? But Facebook and Trader Joe's, yes. The Facebook approach we're all very familiar with, right? They store everything about us, our names, our addresses, all that stuff. But what about more of like a medium-sized company like Trader Joe's? So Trader Joe's, that you walk into a store, you have the customer shopping experience, you go to pay for something, and they obviously keep track of that. But they're not super tech. So what do they really do with that? So they're going to hire a company like Salesforce. Salesforce will come in and they will kind of just help you visualize your data and make it so it's useful. This is really important for companies to so they can see how the trends are, where to invest, kind of what products aren't doing so well, and which kind of products are doing better. So a company like Salesforce or SaaS or SAP are kind of all software as a service, kind of help you visualize your data. So because there's a lot to learn from your data. So those are how kind of more of the normal companies would use data and big data compared to like Facebook, where they kind of just know how to use it. What about a bigger company like Amazon? How are they going to do it? Obviously, they're going to store a lot about you, right? They're going to store the 200 rolls of toilet paper you just bought. They're going to store every episode of Westworld you just binged, everything. So they're going to use this data in many ways. Obviously, they're going to use this to recommendations are a big one, but also things like customer support where they already know kind of what your name is, where your address is, and they also use this to kind of review logs, the logs of data to give everyone the best service possible. So how does Amazon really stack up against these three V's we were talking about? Well, their actual volume of data is really hard to find for big companies. But Facebook actually had an article on their actual website that said one of their data warehouses, Hive, has 300 petabytes of data and 800,000 tables, and Facebook generates 4 new petabytes of data every day. And then obviously going back to before, where we talked about 1 petabyte is kind of that threshold. So then Facebook, and that's why I kind of comparing Facebook to Trader Joe's, and these bigger Facebook, Amazon companies are just like a whole other threshold of big data. And then velocity of Amazon would be instantaneous. You could look up one movie with James Spader in it, and then you go back to your own page, and it's recommending every single season of Boston Legal or something like that. And then plenty of variety from Amazon, right? They have your purchases, they have the things you view, they have all your names, they have all your addresses, they have a lot of stuff. When you watch things, when you're active, stuff like that. So why is big data important? Why should people care? First, what about companies? What's invulnerable to them because it helps them make much needed insights to make business decisions. Tells them what's working, what isn't working, and they turn this into better business, and that means more profits and more money. It's also a really good idea for these companies to have the best big data service possible they can. It helps them stay organized and it helps them save money both on the service and then they'll make money in the long run by just making the best decisions with this big data service. What about the average American, the average user? Why should we care? Well, it really impacts everything. Helps healthcare systems predict new diseases. It helps stores make better businesses for us. It can even help new products be created based on the usages of our other ones. Really, big data is all around us and it impacts everything.
Security is important in big data and in data management in general. But first, we need to talk about the tools that make big data become more manageable: MapReduce and Hadoop. MapReduce is a programming model and an associated implementation for processing and generating big data with a parallel algorithm on a cluster. The MapReduce framework sorts the output of the maps, which are input to the reduce task. Typically, both the input and output of the job are stored in a file system. Hadoop is a collection of open source software utilities that use a network of multiple computers to solve problems involving massive amounts of data and computation. Hadoop can be split into modules, which each carries out a particular task, which are: number one, distributed file system. The distributed file system allows data to be stored in an easily accessible format across a large number of linked storage devices. Number two, MapReduce. Hadoop also implements MapReduce, which has two basic tasks: reading data from a database, putting into a format suitable for analysis, which is the map, and performing mathematical operations, which is the reduce. Number three, Hadoop Common. Hadoop Common provides tools in Java since Hadoop is built on two technology, Linux OS and Java. This is needed for the user's computer systems to read data stored under Hadoop file system. Number four, Yarn. Yarn manages the system storing the data and running the system. Even though Hadoop and MapReduce provide convenience, they are not the most secure because they were created and implemented before security was a huge concern. Next, we talk about common challenges and issues with big data security. Big data is a very important resource for many big and small, but with this huge volume of various data that tends to have a high velocity comes many security issues. Just to name a few, number one, fake data generation. Cybercriminals can generate fake data and place that data into a company's data pool, which can badly affect a business that runs off of IoT or rely on real-time analytics. Number two, granular access control. This grants different users access to different levels of a company's database. As a company's database continues to grow quite large, the granular access control can open companies to vulnerabilities due to having a handful of people having access to a particular data set because it may take longer for a breach to be noticed. Number three, outdated frameworks. Frameworks like Hadoop or MapReduce lack basic security measures like encryption, which can make a system vulnerable because they were made before security was an issue. Number four, lack of security audits. Security audits can measure how well a security at a company performs, and with big data already encompassing many challenges, a security audit just adds another thing to do. It can also be assumed that not all companies have qualified employees to implement an effective security audit. Number five, lack of funds. Some companies just deem extra security precaution unnecessary or procrastinate on it as if it was not an immediate problem, or maybe just don't have the funds to have a proper security. With major data breaches hitting bigger, well-known entities, a search for where and how the breach occurred and to strengthen the security are always problems always attempting to be solved. These breaches of data show no signs of slowing, so big enterprises and businesses need to realize the importance of security because it can be costly to the business, customers, and employees. There is an urgency in big data security where the importance of needs to be realized to minimize vulnerabilities and stop data breaches. Next, we talk about why is big data security important? The simple answer is to protect the data. Most to all companies are using some form of data, and one data breach could have massive repercussions. If a security breach occurs, it would result in even more legal repercussions, reputational damage, loss in money, and employee and customer information being leaked. Many companies are using technology to store and analyze petabytes of data about a company, business, and customers. As a result, information classification becomes critical. For making big data secure, techniques can include but are not limited to: number one, encryption. Encryption is encoding the information so the data is more secure. Number two, logging. Logging keeps record of all data, input, processes, and final results in a program. Number three, honeypot detection. Honeypot detection is a proactive defense technology in which resources are placed in a network with aim to observe. That concludes security challenges in big data as we went over Hadoop and MapReduce, common security challenges and issues, why big data security is important, and potential solutions for big data security.
Data quality assurance is the process of profiling data to discover inconsistencies, inaccuracy, incompleteness, and other anomalies in data. In general, big data quality assurance refers to the study and application of various assurance processes, methods, standards, criteria, and systems to ensure the quality of big data in terms of a set of quality parameters. These parameters consist of data accuracy, data currency and timelines, data correctness, data consistency, data usability, data security and privacy, data completeness, data accessibility, data accountability, and data scalability. Data accuracy refers to the closeness of results of observations to the true values or values accepted to be true by their users. Data currency and timelines measure how up to date data is, whether it is correct despite changes that can impact time and date values. Data correctness evaluates the correctness of collected big data sets in terms of data types, formats, and profiles. Data consistency evaluates the consistency of a given data set in different perspectives or systems. Data security and privacy evaluates how secure these datasets are in different perspectives. Data completeness measures how complete a big dataset is within a selected domain. Data accessibility evaluates how easy the dataset can be accessed for its users. Data accountability is evaluated in many ways but is a very important factor for the application and user. Finally, data scalability evaluates on how well big datasets are structured, designed, collected, stored, and managed within a large-scale service. Data validation, on the other hand, is a method that checks for the accuracy and quality of data, typically during the importing and processing of data. Data validation ensures that data is complete, unique, and within the range of values that are consistent to what the user is expecting. It can ensure that when data analysis is performed, the results are accurate and correct. However, the data validation process is very time consuming but can use several tools that can help the process. The data validation process consists of data collection, data cleaning, data transformation, data loading, and data analysis. Data collection is the process of gathering and measuring information on targeted variables in an established systematic fashion which can answer relevant questions and outcomes. Data cleaning is the process of detecting and correcting corrupt or inaccurate records from a database. Data transformation is the method of converting a set of data values from one data format to another, such as transferring from one system to another. Data loading refers to activities in which big data is loaded into a repository such as Hadoop environment or a NoSQL big database. Data analysis is the process of inspecting, cleaning, transforming, and modeling data with the goal of discovering useful information to predict conclusions and support decision making. To aid in all of these methods, there are several tools that are available that help the data validation process be less time consuming and challenging for a user. There are a variety of different tools that perform very differently from one to another. Some of these tools consist of Data Mirror, Talend, Microsoft Azure, HD Insight, Informatica, IBM Query Surge, C3 Integrity, and Jumboon. These are all very different applications and have a variety of uses that can work on different formats such as text files, CSV files, HTML, JSON, XML, and even database formats. These applications can be involved in a variety of different sectors, such as being used in education, finance, healthcare, manufacturing, media, and other services. Despite having several uses within different industries, organizations must overcome the challenges that exist with big data quality assurance. Several factors can cause quality assurance challenges. Furthermore, these four issues are the main causes of quality assurance challenges within big data. First, lack of awareness and good understanding of big data quality validation assurances. Second, the lack of well-defined enterprise-oriented big data quality assurance standards and programs in assisting data validation, control, and management. Third, the lack of available research results on big data quality models and quality evaluation metrics. And finally, the fourth issue is the lack of well-established big data certification programs and standards. Several reasons behind needing quality assurance and validation exist in three different perspectives, such as through management, processing, and quality of service. Some problems that quality assurance and validation hope to solve consist of issues that cause higher costs for enterprises and businesses, inefficient service operations, reducing and affecting business revenue, and affecting the accuracy of data analysis. Furthermore, poor data quality could cause financial issues for a business, such as totaling as high as from 40% to 60% of an organization's expenses. It's stated that most companies don't actually understand their data quality. Additionally, untrustworthy data can result in wasted time and resources for an organization. It can harm efforts to maintain accurate customer records, purchase histories, and relationships with clients, leading to revenue loss for a business. When poor quality data enters the complex system of enterprise data, even a small error such as a typo in a street address or a part number can lead to revenue loss, process inefficiency, and failure to comply to industry and government regulations.
An important challenge that needs to be processed while dealing with big data is data extraction. The collected data is mostly not in the format required for processing. For example, the health records of a hospital can comprise of medical reports, prescriptions, readings captured from sensors and monitoring machines, and image data like X-rays. Can we utilize this data effectively while they are in different forms? The answer is no. We need to build an extraction process that pulls out the required information from the big data source and formulate it in a standard and structured form ready for analysis. Creating and maintaining this process correctly is a continuous challenge in big data. The design of extraction process is highly dependable on the application area. For example, the data you pull out from an MRI is different from that you pulled out of a picture of the stars. Data cleaning is another important challenge in the field of big data. Data cleaning is the process of detecting and correcting or removing corrupt or inaccurate records from a record set, table, or database. The major purpose is to detect and identify incomplete, incorrect, inaccurate, irrelevant data parts in a data sets, and they can be replaced, modified, or deleted. The big data is not always telling the truth. In fact, it may carry some fake information. For example, patients may intentionally hide some risky behaviors or symptoms which might lead the physician to misdiagnose the condition, or patients may sometimes give wrong names of the drugs they were taking before, which leads to inaccurate medical records. This will necessitate using data cleaning techniques which comprise of well-controlled constraints to valid data and well-verified error models to ensure the quality of the data. Data modeling and query processing is the next big challenge in big data that we will touch on. The modeling and query processing part of big data are strongly related to mining big data. Techniques to query and mine big data are significantly different of those used for the analysis of traditional data sets. Big data is often noisy, unreliable, heterogeneous, dynamic, and interconnected data. However, the noisy big data might be more useful than small samples of data since General statistics can be extracted from repeated patterns, and interrelation analysis usually overwhelm the individual variations and reveal more hidden knowledge. In addition, big data forms a large interconnect network of heterogeneous information and redundant information which can be analyzed to compensate for the missing data, to check unreliable relationships, to verify contradicting conditions, and to disclose the hidden models. The data mining itself can assist to improve quality and reliability of the data, explain its semantics, and suggest intelligent query functions. Knowledge extracted during analysis and mining can help to correct errors and remove ambiguity. For instance, a physician may diagnose a patient case as DVT, which is used to refer to both diverticulitis and deep vein thrombosis, which are two dissimilar medical conditions. Digging into related data, such symptoms or medications will help to determine what the physician meant. Big data is the main enabler for the next generation of interactive data analysis, which provides answers in real time. This new generation will enable querying the streams of big data. For example, the content of websites to populate hot lists, provide instant recommendations, and to provide ad hoc analysis to decide if it is worth to store or discard a dataset. At the end of the day, the result of the analysis will be presented to the decision makers to interpret. It often includes testing all the assumptions made and reviewing the analysis. As shown already, errors can emerge from different sources. Faults in computer systems, assumptions made for the models, and erroneous data on which the results are based. The end user needs to understand and verify the results the computer systems generate, and the computer system must ease the job for the user. However, due to the complexity of big data, this becomes a challenge. Assumptions are there since the beginning of the journey. Important assumptions are made initially behind the captured data and also again through all various steps of the analytical pipelines, which are based on built-in assumptions. As an example, the recent mortgage-related crisis to the financial system clearly justifies the need for decision-maker diligence who should examine closely all possible assumptions at the various stages of analysis. It is not enough to give just the results. Instead, one must provide the additional information describing how each step is derived and what inputs are used. This supplementary information is called the provenance of the data. However, more research should be performed to find out the best methods to capture, store, and query provenance in conjunction with the techniques to create adequate metadata. By this, users will have the infrastructure required both to interpret the results of analysis and to redo the analysis with different sets of assumptions, parameters, and data.
Big data is a very advantageous technology that can benefit businesses big and small. Aspects of this technology can benefit businesses by providing three main values: cost reduction, decision-making improvements, and improvements in product. Yet big data can be very advantageous. Big data can also have many challenges and issues that include, but are not limited to, management or security challenges, data quality challenges, validation issues, and processing issues. Terabytes to petabytes of data flowing every day have revealed that current infrastructures are not sufficient enough to meet the challenge. So good practice and the constant creation of technology are used to manage both challenges and issues that arise. Big data is nowhere near perfect, nor are we capable enough to manage the huge quantity of data there is. Even so, big data technology can be very useful, but needs a substantial amount of management to stop issues from occurring. That concludes our presentation on big data and big data challenges. Thank you for listening.